right? So the first thing we want to start off with, according to your rules, it says to convert this statement, this is a statement, to a word equation for the reaction. So let's go with that first. Let me get down to business. So this is magnesium, right? Magnesium is added on to hydrochloric acid to give me, I have here, whoops, don't do that at all. To give me magnesium chloride plus hydrogen. So we have a word equation. The next thing we need to do is we need to convert the words to symbols and formulae, right? Now, folks, I'm going to navigate using your Google Classroom where the notes are. So you'll know what we using as additional guidelines for this topic, right? For elements that are by themselves, it's not compounds, guys, the elements by themselves. I have a whole beautiful note here with the periodic table, with a periodic table as well, right? So for elements by themselves, we will get their symbols of the periodic table. So I have magnesium, right? Magnesium is Mg, so I switch back, I write down my magnesium. You all with me so far?
Yes.
All right. Hydrochloric acid, right? It's a covalent compound. So I will give you the formula for that, which is HCl, right? Common L. I don't know why I keep putting capital. Right, common L. And don't worry, I'm going to give you that after so you'll know what formula is attached to the different acids. Magnesium chloride. Now, magnesium chloride is a metal and non-metal compound. Magnesium is your metal and chlorine is your non-metal. So I want you to make reference. So we come out of this note here. We had done some writing formulae, naming compounds and writing formula. I have a bit of notes here, right? I want to view the material. So this is a metal and non-metal. I have like for the other compounds to post for you guys, right? So we're using this here as a guideline to be able to write, to be able to come up with a compound name for magnesium chloride, right? According to these rules here, when you're writing the formula for it, you write the symbols of each element, determine the valency, exchange the valency, find the lowest whole number ratio between the valencies, right? So let me show you pretty quickly how to do the magnesium chloride, how to write the formula, right? I'm just writing it here because I'll clear it after. Magnesium has the symbol Mg. Chlorine has the symbol of Cl. We have to get valencies. The valencies are dependent on the groups in the periodic table, where the elements are placed on the periodic table, right? You can pull the periodic table and have it on standby, right? I know the groupings offhand, so I'm just going to use it offhand there one time. Magnesium belongs to group 2 on the periodic table, so it has a valency of 2. So I write that down there. Put that there. Chlorine belongs to group 7. Again, use your periodic table, guys. Make sure you have that periodic table. Look for your chlorine. You see it in group 7 of the periodic table. You say, all right, the valency is 1. Write down the 1. I need to exchange the valencies because I see the next part of the rule that comes. So magnesium takes the 1 from the chlorine and chlorine takes the 2, sorry, from the magnesium. And you get this as your formula next. MgCl2 for the formula of magnesium chloride. We don't write the 1 in the formula. We don't put Mg1Cl2 because the 1 is understood. So I write that in here now. I find my formula. I'll put MgCl2. You all with me so far? Yeah? Hydrogen by itself, hydrogen is a diatomic molecule. You write it as 2, right? Now, one important part, guys. We need to put in the state symbols, right? So, magnesium is a metal, so we put Mgs, right, which represents a solid. Your chlorine is, your hydrochloric acid is aqueous, so you're putting that there. This will also be aqueous when reacted because it will be formed from that, and we're gonna get a gas over here. Here comes the fun stuff. So we need to balance this equation. So what I just do, I will always tell my students, draw this little table. This little table is going to be so beneficial for you when you have to balance equations and you're not accustomed. You're putting all your reactants on one side and all of your products on the other side. Then we tally to see how much atoms of each are present on either side, and then we balance from there. Magnesium is 1 on the reactant side. There is no number in front of magnesium, no number behind it, so it's 1. Same applies to the products on that side. Hydrogen is next on the lineup. Hydrogen is 1 on the reactant side, but hydrogen is 2 on the product side, so it's not balanced. Chlorine on the reactant side is 1, but chlorine on the product side is 2 because there is a number underneath it. So we notice that there is some imbalances there. Are you all with me so far? Please confirm. Are you hearing me?
Okay.
All right. So we go in. So check it out. I have more hydrogens on the reactant side than I'm on the product side than the reactant side. So I need to come back here to fix this. In order to balance, we have to do some multiplication. So 1 by 2 will give me 2. The number that I have multiplied by, guys, has to be applied. You're not using the answer, the product of the multiplication. You're using the number that you multiply by. So that 2 now that I put here needs to go in front of the HCl. I cannot put that 2 next underneath the I cannot put it 2 underneath the chlorine here, like how it is here for the magnesium chloride, because I'm gonna change the formula, the chlorine, and I don't want to do that. I want my formula to stay, right? I don't want to change the formula. We're not changing the formula. We're just trying to balance the equation. So anytime you're balancing an equation, you need to write the number that you're balancing, you're using to balance at the beginning of the the compound, not inside of the compound, because you're gonna change the formula. We don't want to do that. So
Hi, Miss Excuse.
I
I'm sorry to cut you. The screen that we are seeing here right now is where you have these steps to write the formula. You don't have
also
the yeah. So I think you was talking, but we wasn't getting to see exactly what you were talking about.
no
Sorry.
problem. Right. So this here now, this 2 not only applies, not only applies to the chlorine, but it also going to apply to the hydrogen there now, right? So now the hydrogen, which was originally 1, is also going to be multiplied by 2. So 1 by 2 gives me 2. And we do a little double check to ensure that everybody is balanced. 1 magnesium, 1 magnesium. 2 hydrogens, 2 hydrogens. 2 chlorines, 2 chlorines. So equation there is balanced, right? Take this down, then I'm going to give you the state symbols next. And when you're finished with the state symbols, I'm going to do a couple more balancing with you all so that you guys understand this, and then we're going to try some together. So let me know when you're done. All right, so I think Kyle finished. Anybody else finished?
Yes, I'm almost finished.
Okay.
All done, miss.
Okay, waiting on everybody, right?
Miss, I'm finished.
All right, Keelan is finished. Anybody still writing?
No, miss.
All right. Bharat, you finished? Mateo?
Yes, I finished, miss.
Okay, nice. Ashley?
Finished, miss.
Okay, good. Give me a minute. Let me get the state symbols for you guys, right? So you have it. And always remember, groups 1, 2, and 3 on the periodic table are metals. I repeat, groups 1, 2, and 3 are the metals on the periodic table. Covalent compounds are non-metals and non-metals. I had made an error here. Non-metal and non-metal compounds. So I have it in non-metal and non-metal compounds. Gases are non-metals. Anything that is aqueous is a salt, a hydroxide, or an acid, right? Majority of the times it is used hydrochloric acid, right? Or sulfuric acid, which is H2SO4, but we are dealing with that one as yet. All right. So when you're finished jotting down this little piece, let me know, and I'm gonna go with example number 2. Guys, excuse me for 2 minutes. You need to use the washroom really quickly. I'll be right back, and then we're going into example number 2. All right, let's do this. Let's go into the next example, right? Stop and share. You all seeing the screen, right?
Yes, miss.
Example. Right. So, oh God. Right. Magnesium and oxygen react to form magnesium oxide. They want you to write a balanced chemical equation for the reaction. Now, like I said, these things I know off the top of my head. I need you to refer to your periodic table for these, right? So we write in the word equation first. Magnesium plus oxygen gives magnesium oxide. Next thing we need to write there is the symbol equation. You're all following the plan so far, right? Mg is for magnesium. Remember this, magnesium is a solid because it's a group 2 element. So you put Mg, G in brackets, sorry, S in brackets, my bad, S in brackets. Add on to O2. Remember, oxygen is a diatomic molecule. Anytime you see it by itself, it will be O2. Oxygen is a gas, right? So we make sure we put that in there. To give me magnesium oxide is going to give you a solid, right, guys? Magnesium oxide is going to be a solid. So I'm doing the formula writing on the side here. So you write the symbols, MgO. Magnesium belongs to group 2 on the periodic table. So the valency is 2. I put 2 there. Oxygen belongs to group 6 on the periodic table. So if I want to find out the valency for oxygen, take 8 minus, you're taking 8 for elements from, let me tell you, for elements from group 4, come down to group 8, or I should say group 7. The 8 don't have no valency. For elements from group 4 to group 8, if you want to find the valency for it, you take 8 and you minus it by the group number. In this case, the group number for oxygen is 6. 8 minus 6 gives you 2. So the valency for oxygen is 2. So if you don't remember the table, but you can remember the group number, take the 8 and minus the group number from it, and you will get the valency. Next thing you're doing, exchanging. Magnesium taking the 2, oxygen taking the 2. So you end up with Mg2O2. And in cases where the valency could divide into a number smaller, them 2 numbers there could further simplify. It could simplify into something smaller. Those 2 numbers are actually divisible by 2. So you could divide by 2 to get a smaller number. Stay with me. 2 into 2 magnesium is going to give you 1. 2 into 2 oxygens is going to give you 1. So your final formula for magnesium oxide is MgO. Y'all with me so far?
Yes, miss. Yes, miss.
Nice, good. Mg. Scroll down. Drop my table. If I know I'm not too confident in this, and like I said, magnesium oxide is going to be a solid, right? So I make sure I write my state symbols, and all too, like the examiner is just be looking for the state symbols. Even if they tell you, they don't tell you in the exam they want it, so write it here. Your grade profile will go up because they look at your knowledge and your expression. And when you're putting these things, they realize that you have good grasp and understanding of your material and you can express yourself properly. That's the way to get a grade 1. So magnesium on the reactant side is 1. Magnesium on the product side is 1. Oxygen on the reactant side is 2. But oxygen on the reactant side, the product side is 1. So to get 2 on this side, 1 multiplied by 2 gives me 2. I come and I put that 2 in front of the MgO. That 2 applies to the Mg as well. So we 1 by 2 Mg to give me 2. I could get 2 here. Multiply my 1 by 2 to get 2. And I just went up at 2 in front here. And now everybody business balance. 2 magnesiums, 2 magnesiums, 2 oxygens, 2 oxygens. And my equation there is balanced. Questions, anybody?
No, miss.
All right. Take this one down. And then I'm going to do one last example. And then we're going to try some. Kyle, we don't write the ones because the ones understood. If we didn't have it, well, if we didn't have the element there, if we didn't have the element, we would not have write it in. So the 1 is understood. So we don't have to write MG101. We write MGO.